Welcome back. We're going to be looking at the scale and measurement of distances. So first off, let's look at the definition of what a scale is and what measurement is. So a scale is a fundamental concept that plays a crucial role in understanding maps and spatial relationships. It refers to the relationship between the distances represented on a map and the corresponding distances on the Earth's surface. So essentially, understanding scale is essential for accurately interpreting maps and measuring distances at the same time. Scale allows humans to actually, in this case, gauge the size of or to what extent a size of a particular feature is depicted on the map. So that's basically what that definition of what a scale is, and then the measurement joined together. So with measurements, in this case, scale can be referred to as the relationship between measurement on the map and the corresponding measurement on the Earth's actual surface. Or we could say the Earth's physical surface. So next topic we're going to look at is representative fraction, or we could call it RF for short. So representative fraction scale. Representative fraction scale, or the RF scale, is a scale that is also known as a ratio scale. It is used to actually express the scale as a ratio or as a fraction. And what scale are we talking about? The scale of a map. So essentially, we can say that the RF scale is a way of showing the relationship between distance on a map and the distance in the real world. And it is usually written as a ratio or a fraction, like 1:50,000. So this actually means that 1 unit of the measurement on the map, like an inch or a centimeter, equals 50,000 of those units in real life. So next, we're going to look at the verbal scale representation. So the verbal scale, in this case, is a scale using words rather than numerical ratios. For instance, a verbal scale might be 1 inch equals 1 mile, or 1 centimeter equals 100 kilometers. So verbal scales, in this case, are straightforward and easy to understand, making them useful for general audiences, as well as in situations where numerical ratios may be less intuitive or less effective, as the case may be. So graphic scale, or in this case, bar scale. So you could actually call it graphic scale, or you could call it bar scale. So the graphic scale, also known as the bar scale, is used with a line or bar marked with distances. So that corresponds to the actual ground distances. What this graphic scale actually does is actually giving you kind of like bar or lines on with distances which actually correspond to the actual ground distance. And when we say actual ground distance, we're talking about the actual physical distance on the Earth's surface. So users can measure distances on the map that has to do with the graphic scale, that has a graphic scale or a bar scale. Using the graphic scale, comparing the length of features on the map to the distances and represented by the scale of the bar specifically. So next is actually the fractional scale. So the fractional scale represents scale as a fraction without specific units. For example, scale of 1:100,000 indicates that 1 unit of measurement on the map is equivalent or represents 100,000 of the same units on the ground. And when we talk about the ground, we're talking about physically. So fractional scales are similar to representative fraction scales, but may lack explicit units and making them less precise for certain applications. Next, we have the linear scale. So on a tourist map of a city, a linear scale is typically found at the bottom or side of the map. It may be labeled as 1 inch is to 1 mile. If a tourist wants to walk from one attraction to the other, they can actually use the linear scale to estimate walking distances between measuring the distance on the map and converting it into miles to actually know if it's actually trackable or if they'll have to use a vehicle to actually get to that particular point. So next we have the diagonal scale. So in the surveyor's map of a hilly terrain, a diagonal scale can be used to measure distances along slopes or inclines. Surveyors can use this scale to accurately measure the length of roads, property boundaries, or contour lines that follow diagonal paths across the different landscapes. Next, we have the isomorphic scale. So in the
thematic map showing popularity or population density in a region. An isomorphic scale maintains equal distances and proportions between features. Features in this case could be monuments, could be buildings, could be actual physical bodies that actually they're naturally occurring physical bodies. So this ensures the relative spatial relationship between population centers accurately reflecting the distribution of the population density across that particular map, or in this case across the particular location that this map covers. So each type of scale serves a specific purpose and is applied in different geographic contexts to aid in navigation by planning and analyzing the data that comes from it. So by actually using this particular scale and understanding how to use this scale effectively, geographers, planners, and map users can accurately interpret information and make informed decisions about a geographical phenomena. Phenomena in this case, it could be, let's say, an earthquake or a particular thing that happens, maybe natural disaster. Next, we're going to look at converting scales in geography. So conversion of scales in geography is essential for accurately interpreting maps, conducting analysis, and making informed decisions, which is based on data that have been collected over time. So conversion involves translating measurements and distances between different scales, allowing the map to user to be able to relate information that is visible on the map to the actual physical location or the real world distances that the user is actually going to have to traverse. So what we're also going to look at under the conversion of these scales or converting these scales in this case is understanding the scale representation. So different types of scales such as linear scale, graphic scale, representative fraction, which is the RF scale, represent scale relationship in various ways, which could be, for example, the linear scale typically uses ratio or verbal description to express a scale, while the graphic scale uses visual bars or lines marked with distances. On the other hand, we also have the RF scale that expresses scale on ratios such as 1:50,000, indicating that 1 unit of measurement on the map represents 50,000 of the same unit on a physical plane. So how do you actually convert these scales? So converting linear scales, that's the new topic we're looking at. So first thing you have to do is to identify the scale. In this case, by determining the scale of the map, which is usually provided on the map legend or title. For example, if the scale is 1:50,000, it means that that particular unit, that 1 unit on the map is equal to 50,000 of the same units on the ground. Like when we're talking about on the ground, it's like physical distance. Secondly, next thing you would need to do is to measure distance on the map. So for example, you need to measure the distance on the map between the 2 points on the map using a ruler or other measuring tool. But you also have to note that the measurement in the map's units is what you're supposed to use, which in this case, it has to be in inches or in centimeters. And then thirdly, the next thing you need to do would be to calculate ground distance, which in this case, you need to multiply the measurement or the measured distance on the map by the scale factor. For example, if you were using a particular map and then you got a particular figure of 4 inches, and then the scale is 1:50,000, the ground distance would be 4 inches multiplied by 50,000, which is going to give you about 200,000, which is, in this case, approximately 3.16 miles, assuming 1 inch is equals to 63,360 inches. Next, we're going to look at how to convert area scales. So first thing you have to do when you're converting area scales is to determine the scale of the map as described in the particular map, and then measure area on the map. So in this case, what you need to do is to measure the area of interest on the map using a ruler or other measuring tools. And also, you also have to note that measurements in the map units squared. So in this case, you square, for example, square inches, square centimeters. That's actually what you're going to use. So you calculate the ground area. To calculate the ground area in the converting in the area scale, what you need to do is to multiply the measured area on the ground by the square of the factor. For example, let's say you measured on a map and the measurement on the map is 16 square inches. Now, what you need to do is to check the scale, and let's say the scale is 1:50,000 on the ground area. That would be 16 square inches multiplied by 50,000 raised to power 2, which is about 4 million square inches, or approximately 25.4 square miles. Not really a difficult math to do. It's kind of simple. So let's look at an example. Suppose you have a map with scale of 1:50,000 specifically, and then you want to find the ground distance corresponding to the measured distance of 6 inches on that same map. So what you need to do, let's look at the calculation. What you do is to look at the map scale, you have to ensure that you state the map scale, which is 1:, in this case, what we're actually using is 1:50,000 measured distance on the map. And then in this case, we have 6 inches. So the scale factor here is actually 50,000. The ground distance, so the formula you're going to need to use would be ground distance equal to measured distance on a map multiplied by the scale factor ground distance, which in this case is going to be equals to 6 inches multiplied by 50,000 ground distance, which is equals to 300 inches. So to convert inches to miles, what you need to do is to divide 63,360. And the reason why you're going to have to divide it by 63,360 is because 1 inch is equals to 63,360 inches in reality. So that would mean ground distance in miles would be equal to 300 inches divided by 63,360 inches or miles of ground distance, which is going to be equal to 4.73 miles. So in this case, a measured distance of 6 inches on the map will correspond to 4.73 miles on the ground. So these calculations will provide a straightforward method for converting scales in geography, allowing maps users to interpret measurements accurately and make informed decisions based on the geographical data that is available. So next we're going to look at scaling gradients to and fro from map reduction and also enlargement. So basically scaling to gradients and map reductions and enlargement. So firstly, applying scales to gradients and map reduction and also enlargements in most cases involves understanding the relationship between map distances and real world distances, as well as how these relationships change when maps are resized or gradients are calculated. So next we're going to look at applying scale to gradients. So gradient or slope on a map represents the rate of change in the elevation over a certain distance. To calculate gradients using scale would have to follow a specific step. So essentially the step we'll be using would be to measure horizontal distance on a map, determine the elevation change, and also calculate the gradients, which essentially that would be gradients would be equal to horizontal distance, which is called the run, divided by elevation change, which is called the rise. So applying scale to map enlargement. Map enlargement involves scaling of the map to a larger size, which also maintains the proportionality of the features on that particular map. So the steps would be to determine the original and new scale, which is the case where you have to establish the original scale of the map and then the desired new scale. Also, you need to calculate the enlargement factor. The enlargement factor is the ratio of the new scale to the original scale. So enlargement factor is usually equals to new scale divided by the original scale. So in order for you to be able to apply enlargement factor, you need to multiply the dimensions of the map feature by the enlargement factor to get the new dimensions that you're actually trying to generate. So next thing we're going to look at is the directions and bearings to geographical features. So the directions and bearings to geographical features, in this case, the bearings are crucial for navigating, mapping, and analysis, both concepts for essential accuracy, describing the location and the orientation of the objects or place in relation to one another. So in this case, we look at the direction. So we have the direction, which first of all, it's the cardinal point you're looking at. So when we're talking about the direction, it's the cardinal point. So that helps in navigating and orienting oneself. The primary directions are north, south, east, and west, which are denoted as N, S, E, or W on the map. So in addition to these primary cardinal points, there are intercardinal points or ordinal directions that lie halfway between the cardinal directions, which we have things like the northeast, that's NE, we have the southeast, SE, the southwest, that's SW, and we have the northwest, which is NW. So next, we're also going to look at the bearings. So the bearings are used to describe directions of one point from another using angles. Bearings provide a more precise way to specify directions compared to cardinal points, which is just giving you the north, the south, the east, and west. But the bearings are measured in degrees from a reference direction, usually from north in a clockwise direction. So basically, bearings are classified into true bearings, which is measured from the geographical north, which is called the true north, the magnetic bearing measured from the magnetic north, which can differ from the true north due to the Earth's magnetic field in variations which change over time. And we also have the grid bearings, which is used in mapping and surveying, measured for grid north and also map projections. So bearings are typically represented in degrees from 0 degrees to 360 degrees. We have 0 degrees or 360, which is due north, 90 degrees, which is due east, 180 degrees, which is due south, and 270 degrees, which is due west. So essentially, we've come to the end of this particular topic. We have looked at what a scale and measurement is. We've looked at the converting scales, and we've looked at sealing to gradient map reductions and map enlargement. We've also talked about directions and bearings to geographical features. Thanks for listening.